Cisco's having a rough week. Two major bugs just came out, one in SNMP and another in their VPN stack, and both of them made their way into CISA's KEV catalog, which means they're known exploited vulnerabilities, meaning hackers are actively using them today as we speak. I want to go over them for two reasons. One, they're actively being exploited, they're kind of cool. But two, the scoring on these, the bug scores they got are kind of weird. I want to talk about why I think that is. To go into this, first talk about the SNMP bug, SNMP being Simple Network Management Protocol. The way that it works is basically a device has a series of properties that a network admin may want to keep a track of, right? How long has the device been up for? How hot is the CPU? How many failed login attempts have there been? And so to manage these things, you use an SMP manager that basically sucks up all the logs from these devices. And the way that the devices give out the logs is they broadcast the data on port 161 UDP most of the time. That is the SNMP port. And the way that you get the data out of the device is you use this thing called an OID. You basically ask, hey device, give me object number 136121 blah, 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 blah. It's a long string of numbers. And that number is a part of a tree that associates that number to a specific property of the device. The temperature, the amount of login attempts, how long it's been up, etc. Now, the problem with any management protocol that uses binary data is that binary data needs to be parsed by code, and anything that is code can have vulnerabilities. Unfortunately for Cisco, this is not the first time they've had vulnerabilities in their SNMP stack. A similar bug was publicized in 2017, I believe. And there is a POC from, again, 2017, 2018 that shows you how to exploit it. The way that these things work typically is the vulnerability ends up being in the parsing of the OID. So this right here is an OID string. This is literally just a series of numbers that get converted into binary data that is sent to the SNMP server to then parse it and figure out what data to return. So you have to look at the string to figure out, oh, they want, the Cisco, they want the VPN server, they want the number of users logged in, right? Something like that. Now, the problem with this is, like I said, with any binary data, if you don't parse your binary data correctly, there can be buffer overflow vulnerabilities, there can be memory corruption vulnerabilities, and that is exactly what happened in this bug. So the 2017 bug is basically in 5 different OIDs. Actually, no, sorry, it's closer to, what is this, like 10, or I'm not gonna count in public, but all of these OIDs, right, these numbers that are associated to data on the router, things related to the auth framework, the ADSL line card, the voice line card, all of these things, if you query these with the right shape of data, a buffer overflow can occur, and that can be used to hack the device. And this is the exact same thing we're seeing today. So we have a similar vulnerability in a different OID, and I think the OID that is vulnerable is not public, probably intentionally, right, to prevent people from continuing to hack it. But this device, or this vulnerability, affects 2 kinds of devices. Not only the iOS devices, kind of like the more traditional, smaller, Cisco routers, the 2800 series, for example, but also the iOS XE devices, which are kind of the bigger, like, firewall types that are Linux-based, right? These are being called both a denial of service and remote code execution vulnerability, because it's basically, if you query the OID with the right shape, it will corrupt the stack, and the Cisco versions, the non-Linux versions, will flip over, kind of just restart and come back to life. And the iOS versions can be used to get code execution on the device. Kind of a crazy vulnerability. And guys, while we can't stop 0 days from happening, one thing we can do is stay ahead of cyber criminals with today's sponsor, Flare. Flare is a threat exposure management platform that allows you to see if you or your company's sensitive data is actively being sold on the dark web. Here I have my identifiers, like my email address and my domain for Low Level Academy, that is put into the Flare system, and Flare will send me emails on events if they catch my data being sold. Flare actively watches over 18,000 illicit Telegram channels as well as dark web forums to see if your data is being sold. I'm recording this at 9 a.m. and they already have 4 million events collected. Pretty crazy. One of my favorite features is their threat intelligence system. So my channel is a bit of a threat intel feed, right? Talking about CVEs. Threat actor Navigante claims to sell a ransomware as a service targeting Windows and ESXi. This is great for you if you're a company that uses ESXi as your virtualization platform, because now you kind of know, like, oh, there is a heightening demand for ESXi platforms, and there's an active actor selling one right now. Guys, you can try Flare for free right now with the link below. Guys, the best way to help my channel out is to go interact with the sponsors, try their products. Flare, thank you again for sponsoring this video. Back to the video. Okay, interesting discovery. This is a post-recording ad. I'm gonna put this in the middle of the video. So I didn't think I understood exactly where in the routers this vulnerability existed. But typically, if you go to the mitigation documents of what thing you shouldn't allow attackers to have access to, it may reveal to you what is happening underneath the hood. And so you have these firewall rules that basically you add to the router so that certain properties in SNMP can or can't be shown to the user. And so if you look at the advisory mitigation that they put out, they say, oh, if you don't want hackers to hack you, make sure you disable this one specific MIB by default. And so likely this MIB, this OID, is the part of the SNMP stack that is vulnerable. Not saying that it's good that we have this out there, but it's good that you should know how to mitigate. And obviously, if you are a network admin, right, and you're watching this video, a few things. They're recommending that you should be using SNMP v3. Now, me personally, I've never administered an SNMP stack, right? So I don't have a lot of experience with this, but I'm assuming that using more auth is good than less auth. And then obviously, follow their firewall rules, disable, I guess, specifically this MIB to prevent hackers from hacking you. Now, to be vulnerable to these, the attacker needs to actually know the SNMP credentials, right? So depending on what version of SNMP your device is using, versus 1 versus 2 versus 3, it changes the threat model of like who is able to query your SNMP. SNMP 1 and 2 use these things called community strings, which basically it's like just a password, and if you know that password, you can talk to the SNMP server. So, this bug does require knowledge of the community string, but in a lot of networks that I've looked at or a lot of places, people that I've talked to, like the community string typically doesn't change, right? And this is kind of an issue that I have with SNMP in general. I think much like VPN servers, much like SNMP servers, because people think that they are authenticated, because there is an auth wall to access the data, people are like, oh, attackers can't get in. They don't know the password. And it's like, okay, sure. But what if a vulnerability comes out that bypasses the auth because of the way that a thing is parsed, right? Not the case in for SNMP for this bug. But I just think from a network design standpoint, right, even in authenticated protocols that require request signing, that require passwords, you should limit the amount of people that are able to access that data. I'm not going to do it in this video, but if you go to Shodan right now, you'll probably see literally thousands of Cisco routers with UDP port 161 open on the internet that could be vulnerable to this, right? Not a great place to be. This applies for me too to VPN servers, which is the second part of this video. So another bug came out that got a 9.9 CVSS, which I find kind of weird. We'll talk about that here in a second, where Cisco routers basically, if you know the VPN credentials to a Cisco router, if you have like a certificate that allows you to VPN through a firewall, you're able to use that credential to send a malformed HTTPS request to a server, and that would cause it to, some kind of buffer overflow, get codification as root. What I find interesting here though, guys, is that the SNMP vulnerability that I think is arguably worse than this one got a 7.7, right? And the bug requires SNMP to be active. You need to have credentials, but gives you code execution as root, versus this is a vulnerability in the HTTP server that requires VPN credentials as root. And for some reason, it's got a 9.9, it's got a 7.7. I just find it weird. It's more likely, in my opinion, that someone is going to know the SNMP creds and have SNMP access if they can touch the SNMP port, versus them having a VPN credential. To me, them having a VPN credential is like a trusted user, right? This is more of like an insider threat kind of attack, whereas this one's kind of like, someone just guessed public, Cisco, private, whatever. Which is more likely, and for some reason it's only 7.7. Maybe this one's harder to exploit, right? Maybe this is like a command injection or something, and this one's a buffer overflow, so it's more difficult. Not really sure why they chose to go one versus the other here, but it's just an interesting concept. Why, yes, I did change my shirt. Thank you for noticing. Now, the answer to your question, right? Would Rust have fixed this problem? The answer is complicated, right? So it maybe a little bit, sort of. In the case of iOS XE devices, right? XE devices are the ones that are based on the Linux operating system, and inside of the Linux kernel, there is a binary that runs that is like a monolithic binary that could technically, probably, maybe, be rewritten in Rust, right? Because it is a binary that utilizes the kernel to do bare metal access. It is just a user mode program, as far as I understand it. I haven't actually seen it myself, so maybe I'm wrong. That one, in theory, pushed to the side, could maybe be rewritten in Rust to make it memory safe. The issue with I think the more widely applicable version of this bug is the one that affects iOS, not XE, just native raw iOS. The internetworking operating system is a proprietary OS, like an OS on its own that is not Linux, that Cisco owns and maintains. Because of it being a kernel, it is literally a piece of software that's to touch hardware within the router to do things. It requires bare metal access to the device. And if you've ever tried to code embedded Rust is extremely hard to pull off. The whole purpose of embedded software, by the way, is, when you have a chip like this, To make this pin here go hot, you have to write to a specific memory address, for example, right? That concept is referred to as global mutability, the fact that everything globally can be changed. And global mutability, while it matters, is important and embedded, is literally the antithesis of Rust. Rust literally exists to try to prevent global mutability and to try to make coding as defensive as possible, to exercise as much data hiding as they possibly can under the hood, right? So, Rust may have fixed this in certain cases, but organizationally, it's hard to get code bases rewritten, and also doing anything bare metal with Rust is also very difficult. So not 100%. I'll give it a high 3, low 4 out of 10. Okay. Anyway, guys, that's it for now. Thanks for watching. I appreciate it. If you like this video, go check out Flare, sponsor today's video. They do really cool stuff. And then go check out this video. This video that I think you will also enjoy just as much. We'll see you there.